Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analysts podcast. Each week, we discuss our latest data research and a topic related to app development and back-end services. My co-host for the show is Stine of 451 Research. Our show this week is brought to you by Pivotal. Pivotal is on a mission to modernize IT. They bring together this portfolio of cloud and data products with agile engineering discipline. These include Cloud Foundry, Redis, RabbitMQ, and Spring. You can find them at pivotal.io. Now let's get to the show. Hi, Alex Williams here of the New Stack Analysts podcast, here with my co-host Donnie Burkholz, who's just returning from a long week. I saw him Tuesday morning in San Francisco. He went on to Orlando, arrived late last night, and here he is.
Yeah, here I am, still trying to wake up, so we'll try and make this interesting.
And our guest today was Matt Stine, who's also had some adventurous travels this week. Matt Stine is a principal software engineer at Pivotal, and he has written a book called Migrating to Cloud-Native Application Architectures, and we're going to spend a little time talking about the book. Matt, good to see you.
Hey, good to see you guys as well.
And you got in late last night, too, and I apparently you didn't quite ride with everything that you left with.
No, it's eventual consistency at this point.
All right. Well, good luck in getting that bag back. So this is an interesting topic for me. We've been writing about cloud native applications for a few years now, and so it seems like the term has popped back up as something that is a center of conversation. I guess I'm curious, if you have a similar kind of perspective, and perhaps why cloud native applications are becoming so increasingly relevant.
So when I use the term cloud native application architectures, in many ways what I'm trying to do is grab a hold of a bunch of different topics that are being discussed concurrently. So you have the microservices conversation that's going on. You have the 12-factor application concept that Cloud Foundry, Heroku, and others are talking about. You have sort of this emphasis on building applications directly for cloud, or in our case at Pivotal, we're talking about building for a platform. Some people call it PaaS. My colleague Andrew Schaefer hates PaaS, so we talk about platform a lot. But this idea of self-service agile infrastructure, and the idea that your contract between your application code that you're writing and the platform that you're trying to interact with is not brokered by a ticketing system and human beings, but it's brokered by you making calls to some API. And then that kind of bridges over into this general topic of API-based collaboration and creating contracts that you can verify with running code, as opposed to conversations and documents that get passed around. And that becomes sort of the currency lingua franca of the way applications work with each other, the way they talk to services, the way they talk to the platform, and then lastly, sort of this concept that Nassim Taleb talked about in the book Anti-Fragile, and a lot of the stuff he talks about in the book are sort of out of scope for this conversation, but just the idea that there's a concept of systems that assume that failure events are constantly going to occur. Uh-huh. And I'm actually writing about that this morning. And when Netflix started moving into AWS was well known for causing a lot of failures in systems, and a lot of companies suffered because of that. And so they worked from this central tenet that every component in the system should be able to fail, and is going to fail and is going to continually fail. And so we need to design our system such that it will be able to continue providing service to customers, even in the event of one or multiple components disappearing or becoming, having poor quality of service, whatever that may be. And then they take that to the edge and say, not only are we going to assume failures are going to happen, we're going to inject them purposefully in the system and then use the learnings that we garner from that to make the system stronger. And so you end up needing that far more in these distributed systems, and that carries us back to microservices. And we're typically doing this now in the cloud. So you have all of these topic areas that are sort of independent conversations, but at the same time, they seem to be converging on the same people talking about them and the same types of architectures being built. And so I just decided to take the cue from Adrian Cocroft and start talking about cloud native app architectures and apply that as an umbrella term to encompass all of these different things, as opposed to microservices, which is arguably a more popular word to fling around, but is doesn't really capture the sum total of all the things that I think are important.
Donnie, you just returned from a long week of traveling. You've been you talked to a lot of people. In some respect, earlier in the week, we were talking about the level of sophistication in the community out there. I'm curious in the contrast of what you saw this week when being initially at CoreOS, and then it's at the SAP event, and kind of differences in kind of the context what Matt is discussing here.
Yeah, for sure. It's funny because there are actually increasing similarities across both those areas. SAP actually has their own paths, and I'm sure that with the Cloud Foundry Summit, they're going to be in pretty strong attendance if they have been for the past couple of years. They're rebuilding their paths on top of OpenStack and Cloud Foundry and talking about things like Docker containers and all this stuff that, if you thought about a company like SAP 5 years ago, you just laugh them right out of the door if they said Docker, right? You'd be like, oh, that's a joke, right? I mean, like, now we really know everybody is adding Docker support because we can do like ERP and Dockers or something. Like, I don't even know what are you talking about here, right? So, the game is definitely changing, right? And basically, like, every company out there, or at least every vendor out there, has gotten the memo that this is something that's really important and something that matters. And, they want to enable their customers to be able to build, using cloud native architectures, using microservices, however you want to call it. And, I do actually tend to agree with Matt in that, I think cloud native architecture does imply a little bit bigger picture than microservices. Like, microservices is kind of the what, but it doesn't really give you a lot of hints about the how. And I think the cloud native architectures and talking about things like 12-factor, for example, are like, oh, so that's how I build the microservice, right? Like, I know what I want to build. I want to build some kind of RESTful service that's separated at some sort of business level, right? Which is basically how people are, or at least how I understand microservices to be at the moment. Maybe Matt will disagree with me on that one. But then, the how is basically cloud native architecture, which you can break down into largely into the 12-factor approach, plus trying to understand, what do you do with state, basically, in a little bit more modern way. So, I guess to answer your question, these approaches are really converging across the board, right? You've got the new sort of cloud native operating systems like CoreOS, like Rancher OS, like a few other examples. And then you've got, at the other end of the stack, you've got companies like SAP thinking about, like, well, how do we use that stuff to help our customers who are thinking about things like business value, like how to deliver business value. So, you've got the tech all the way up.
It seems to me, Matt, maybe you have some insights into this, is like you can trace almost the evolution of a movement by its language and how that language gets adopted. You use terms in here that are very new to people. We were talking a little bit before about that. How is that, how has it been to communicate these concepts with language that is very unfamiliar to people? I mean, we're talking about terms like the water scrum fall, and, you mentioned things like, strangling the monolith, and you get into choreography and again, this whole idea of these 12-factor apps. I'm curious about your observation in that regard.
Well, I think one of the important things to note about microservices and cloud native and these topic areas is that what they represent is the first major architectural shift that we've seen after we started having the DevOps and continuous delivery conversations. And I had sort of made that observation mentally, but I hadn't really put it into those terms. And then I was sitting in Neil Ford's microservices presentation at a conference just to see what his take on this topic was. And he made that statement, and it really crystallized for me what's happened is that we started thinking about what are better ways to actually deliver value to our customers and do that quicker, do that more continuously, tighten feedback loops. And you have a bunch of people having those types of conversations and inventing language to describe how that might look. And then at the same time, the people who are having the conversations are day-to-day practitioners who are out there trying to build systems and get things done. And rather than, you didn't really have a group of people sitting in a room writing a manifesto for cloud native architecture and then handing that down and saying, here's what this is. You have a lot of companies independently converging. They started with usually a monolith, and then that became too difficult to work with and continue to have the velocity they had when they were smaller and leaner. And so they start breaking this thing apart, and that strangling the monolith phrase that you mentioned from the book, I basically got that from reading a short article that Fowler wrote about strangler applications that wasn't about this topic, but it was very analogous to this topic. And then reading several early blog reports about companies. The one I talk about in the book is SoundCloud and how they moved from this monolithic architecture to microservices. And slowly but surely, other companies are starting to write these experience reports and postmortems of what they did to go from one to the other and why they did it, what things worked, what things didn't work. And so I think what you've seen is that the same types of patterns have emerged and people have started talking about them enough that now we want to start to put general labels on these things. And some of the terms are old. 12 factors has been around for a while, but only recently in my experience has it become something that a lot of people are talking about. I hadn't even seen the word 12 factor on the software conference circuit for years. And then this year I'm on the NFJS tour that I speak on. I've got two different one. I have a session, and there's another speaker that has a session speaking specifically about how to build applications like this. Every software conference I've gone to in 2015, half of the agenda is talking about microservices. And so the conversation is now becoming mainstream, which is very interesting. But then you go, like I did this past week, to sit in a large customer of ours who's now trying to scale this stuff out to a much larger development organization. And there you have a huge number of people who are heads down day in and day out, just trying to get their jobs done. And most of them aren't entrenched in this conversation the way we are. And so it's just like you mentioned, I'm now basically teaching people a brand new language to use to talk about application development before we can ever go do the task of learning the tools and platforms and frameworks and patterns that we have to use to actually build things that way. There's a big crossing of the chasm that we have to do at this point, going from sort of these early adopting groups to the larger majority of people who are trying to deliver code.
So Donnie, that gets back to your point about getting to the how of the matter. What are your observations about what Matt is saying there, especially kind of considering, the time constraints that people have, when it relates to building these cloud native architectures? So does it just make sense for them to use a platform, and try to reduce the complexity and the time issues that are involved in developing these new types of architectures?
Yeah, I mean, certainly, no question about it. If you go back, I guess probably the early to mid '90s, right? Open source, right? That's in essence a composable platform, and almost nobody writes any code anymore at all without using open source code somewhere, right? Like picking up some libraries and using them, picking up some, maybe some code they've contributed to in the past somewhere else. Certainly almost every popular language right now is open source code, right? That's a platform. So yeah, I mean, for some definition of platform, it's basically insane to say like, well, I'm just gonna, do NIH syndrome, not invented here syndrome, like all the way up from the bottom and just do it all ourselves. Well, I'm sure people do that, but they definitely shouldn't be. And it's by no means the majority anymore, right? Like the people that are still writing everything themselves all the way up are definitely in the minority. Whereas people are generally picking up something open source somewhere in their stack, right? And maybe it's, like I said, maybe it's libraries, maybe it's web servers, maybe it's proxies, maybe it's databases. And so, certainly like reuse is the order of the day, and going out there and finding like what makes sense given your architecture and fitting it into that, and what makes sense given, your capability to both, architect for it, code to it, debug it, and, maintain it in production, right? And you have to have or be able to gain all those capabilities. And so it may be that, the best answer is sometimes building some of that yourselves, or sometimes taking a little bit of a different approach. But, I think I said, I don't know, probably 3 years ago at GlueCon that like my vision of the future is absolutely that, everybody is going to build on something that looks a lot like a PaaS. And it's going to have, like the last bastion right now is sort of online IDEs, right? And we're seeing those starting to gain about popularity in terms of like, what does the tool chain look like that developers use? That's sort of the last thing that sits on your box and nowhere else, right? And so once that changes, you'll have basically like technology as a service, right? Imagine if you code and test and deploy all on GitHub, for example.
And so, Matt, to get there to that kind of that platform world, the language then plays a much bigger role, doesn't it?
In terms of how you're talking about it?
Yeah, I mean, for people to even to get to that point, they need to understand the language, or is it more, or is it really not that at all?
No, I mean, there's definitely some of that in that, I think to get to Matt's point about sort of early adopters versus everybody else, you see a very different level of interest in the technology itself versus in what you're going to accomplish with that technology. And so you definitely have to, adapt the language you're using to make it suited to and sort of implying of the benefits you're going to get out of taking a certain approach versus just what the approach is, right? I mean, you've got companies, we were just talking about SAP, like SAP and IBM are sort of the classic, like we sell business value companies, right? Like everything is sort of like marketed to specific industry verticals like oil and gas or, retail or any one of like 20 other ones. And that's the language they use, that's the expertise they have. And they know exactly, like they can say, hey, there's this platform as a service thing, and here is exactly how it will help you, because we know exactly the problems you're encountering and how this fits into those problems. So yeah, the language definitely has to change to get to that sort of point, to get to, the tire company in Rockford, Illinois, who doesn't really care about technology. They don't see themselves as a software company yet. Maybe they will in 10 years, but not right now.
Matt, are you finding companies are starting to see themselves more as software companies, or are they still a long way from that point?
I think the way people see their identity is certainly starting to shift. The number of companies that we're talking to at Pivotal who are now approaching us saying, okay, I see what's happening in these verticals that are sitting next to me, and I'm starting to get the idea that it's about to happen in mine, and I feel like we need to start to reinvent ourselves as a technology company, not because the technology itself is superior, but because we need to start looking at how can we go much faster and validate business ideas, not just deliver stuff faster, but validate ideas faster. I was having this conversation this week that two of the primary reasons why I'm interested in microservices is because they allow me to decentralize the way we get work done and decentralize the governance of that work. And if you take that to its logical conclusion, you almost create this world in which teams are building services, and the services that survive is determined by natural selection. But when you start to make it possible for groups to act autonomously, then you can stand up teams very quickly and say, go validate this idea, rather than we're going to spend 6 months planning and gaining funding for a project that is not going to deliver anything for 2 years, and we have no idea until 2 years is over if it's even a good idea to build the thing that we set out to build. And so companies are starting to realize that that mode of operation is what's going to eventually get them killed. And they're getting this idea that, well, if I change the way I do technology and I start to use software as a accelerator to get me from idea to is it a good idea or not, and then once I know it's a good idea, I start making money off of that idea. If I start to use software to enable that, then I might have a chance at being one of the survivors that gets selected, as opposed to one that gets killed off.
That's interesting. So perhaps one thing might be helpful. I think it'll give a good summary of your book and what you're communicating is you start the book and you give some of these you discuss some of these themes, like, in terms of why go with cloud native application architecture. So you talk about speed, you talk about safety, you talk about, scale, then you get into mobile apps and client diversity and other discussions. And one of the things that actually that I think where it really start to get into the depth of things is when you start defining cloud native architectures. And perhaps it might be just helpful just to go through some of the key characteristics of those cloud native application architectures that you sought to explore. And that, I think, might open some conversation we can have about where, the context of the discussions that we're hearing a lot as we kind of try to cover this whole new world of microservices.
Sure. Yeah. So, where I begin is talking about this idea of 12-factor apps, and 12-factor apps are there's really two things when you talk about the website that Heroku published at 12factor.net. First of all, it is a marketing tool for Heroku. They wanted to obviously help people to build apps that will run well on their platform, so that people will run more apps on their platform. But it was, in my mind, one of the first places where a set of architecture or design principles for writing code was described that represented a loose contract between an application and the platform on which it's running. We've had things like this before. We've had things like, the J2EE, JEE, you write your apps to this spec and the platform's going to provide certain services. But those were more, in my mind, focused on the middleware capabilities that those application servers were going to provide. Here, you're talking a platform that says, you hand me your code, and here are the things that I'm going to do to take that code and transform it into an app that's going to run somewhere, and I'm going to keep it healthy, and I'm going to allow you to scale it horizontally, and I'm going to allow you to gain visibility into, how this application is behaving, what are the events that are coming out of it, what are the performance metrics that are coming out of it. And so they go through these 12 factors to say, if you design your app like this, then it's going to run well in this environment. And when we started doing Cloud Foundry version 2, we also decided to adopt Heroku's build pack model. And in doing that, we started to tune Cloud Foundry very well for these 12-factor apps as well. And then you look at the way Docker starts to guide you in packaging your applications, and you think about, now I've got my application packaged as this Docker image, and I'm going to take that Docker image and I'm going to run it on some platform, whether that's Cloud Foundry or Kubernetes or Mesos or Amazon service, Google service, whatever you pick, doesn't really matter. The way that those platforms are going to hook into your Docker container once it's spun up and give information to it in terms of configuration, and get information out of it in terms of events and logs and how those things will be scaled, they all start to look very similar. And so if you're building for one of those target platforms, which you could loosely bundle under this label of cloud platforms, then this 12-factor idea turns out to be sort of, this is step one. If you want to get code running and running well in an environment like this, that's what you have to do. I then go from 12-factor into microservices, and for me, microservices represent a type of a special class of 12-factor apps, in that 12-factor is, okay, here's what you're going to build in terms of how it runs and how it's designed, and microservices more what you're going to build. What's the demarcation between services? How are they going to relate to business capabilities and segments of the business domain? Start to talk about Eric Evans' concept of bounded contexts and internally consistent domain models. And that starts to give me the guidance on, okay, I'm going to build all these apps. What apps am I going to go build?
Yeah, the bounded context was a phrase that I find very interesting. Can you explain a little bit about what that is to people?
Yeah, sure. So you go back to 2003, I believe it was, when Eric Evans published his book, Domain-Driven Design. He was writing about a lot of the design principles that can allow you to get from a particular business problem that we're trying to solve to a system that's going to not only solve that problem well, but also be able to change effectively and efficiently as the business landscape changes. And he uses a lot of concepts around domain modeling and ubiquitous language and several other things. You get to about chapter 13, I believe it is, of that book, and he introduces this topic called strategic design. And strategic design is moving up from the level of an individual application to design across an entire organization. And he introduces this idea that if you take a company, a business of sufficient size, and you try to describe the domain model for that enterprise, it is very difficult, if not impossible, to actually create a domain model for that organization that's actually going to be internally consistent if you start on the left-hand side and go to the right-hand side. You pick one of any topic that comes up, usually a central component of that business model. When I talk to an airline, maybe it's a reservation. You start to think about Netflix, maybe it's a movie. And you look at those concepts in the different areas of the business, whether it's product catalogs or inventory or shipping or supply chain or marketing, whatever. The way we use those words actually have slightly different connotations.
Mm-hmm.
And what we often try to do then is these large federated data model efforts where we're going to come up with one data model to rule them all. That's going to be the language and the model that everybody in the company uses. And we spin up these big teams and spend lots of time and lots of money trying to create that model. And it almost always results in disaster. And the reason that is because Eric Evans says it's impossible to get that internal consistency. And so he introduces this idea of the bounded context, which is a domain model that is a segment of that larger model that is internally consistent. So as long as at the boundary of that context, you can look at that model and say, each of the terms in the language used by that model have a specific meaning and they're always consistent. You can draw a circle around that thing and say, okay, here is a piece of the model that we can think about that we know what everything means, and we can make assumptions about how it behaves. And that thing's going to have some API. And when he was writing, he was talking about object-oriented language APIs, but it applies equally well, if not easier to work with, when you're thinking about these distributed systems that are communicating over HTTP APIs, because it's very easy to see the boundary between your bounded context and another bounded context, because you have to make a network call to cross that boundary, as opposed to make a method call in some Java or C# code, whatever it is that you're writing your applications in. So that bounded context idea, I think, is the most powerful tool that you can use when you're trying to decide, okay, what microservices am I actually going to go build, and how am I going to divide up the teams that are going to own and build and operate those services.
Now let's take a quick break before we get back to the second half of the show. Our show this week is brought to you by Pivotal. Pivotal is on a mission to modernize IT. They have a portfolio of applications which include Cloud Foundry, Redis, RabbitMQ, and Spring. They're a steward of open source. You can find them at pivotal.io. Now let's get back to the show. Donnie, does this concept of this idea that bounded context help, think a little bit differently then about, microservices and how containers are relevant? It seems that one of the things that, I'm hearing from people is that, microservices have been around for a long time, but there's still been this really almost this reliance, still on machines. And what we're coming to is, this point where like these container processes are working across, essentially just these hosts. And now the data becomes far more relevant, because that data from those containers can be analyzed, which leads to different thinking about how you organize, your teams, because now you're seeing, we need to communicate, in different ways. I'm looking for some clues for, what are the impetus for the conversations we're having right now. I'm curious, if that's something that you agree with, or you're seeing a different kind of a perspective.
Yeah, I mean, I haven't come across that specific term before, but certainly, the way, at least based on Matt's description, the way that it works seems to make sense, right? And I was just trying to look up a page on, one of Martin Fowler's write-ups on exactly the same term to get a better sense of, how a couple different people might talk about these bounded contexts.
Yeah.
And, one of the points that kind of stuck out to me in one of these descriptions, in terms of like where you draw the line, was, so he says, okay, various factors draw boundaries between the contexts. And then the point that stuck on with me is the next thing he says is usually the dominant one is human culture, right? It's culture, it's language, because if you don't have, and we talked about this on the podcast, I think a couple weeks back, if you don't have a shared understanding, a shared empathy of what you're talking about, it's really hard to sort of maintain a microservice that crosses those lines. Whereas within each sort of, group of, I guess, shared language, shared culture, it's a lot easier to maintain a microservice. So thinking about it from that perspective makes a lot of sense to me. And clearly there's going to be sort of other things that help you draw these context lines as well. But one that I particularly like is the one of a shared understanding.
Mm-hmm. So Matt, we talk about the 12 factor applications and and as a key factor in defining cloud native architectures, you get into the kind of this idea of microservices and this concept of the bounded context. And then, there's discussion on the self-service agile infrastructure. Maybe you can help us connect the dots and how you see, for instance, self-service agile infrastructure clearly relates to APIs. But I think this concept of anti-fragility is something that people are still trying to better understand. Perhaps there's kind of a bridge there that you can help explain a little bit. It might help get this concept of anti-fragility, a little bit better understood.
So did you want me to start at self-service agile infrastructure, or you want me to start right? Yeah, okay.
Yeah, and help us understand that connection to anti-fragility.
Yeah, sure. So when I talk about self-service agile infrastructure, it's really, I'm really talking about PaaS more than anything else.
Mm-hmm.
But I don't necessarily want to force everything into that box, because some people are doing what you would call cloud native architectures, and they haven't gone and grabbed a PaaS product per se to go do that. You look at Netflix; they've built a lot of things that you could compose together and turn into something that you might call a PaaS. But the key thing there is that if you look at the way I talk about in the book, that teams that are building these cloud native applications and services, they not only do they build things, but they run things. So kind of borrowing from the Amazon tenet that if you write it, you run it. And something that you mentioned earlier, where we're really, traditionally, we've really had a lot of focus and running applications on, we're running machines somewhere, and the code that we're running maps to a machine. And so the currency that we're thinking about in terms of deployment is still focused on a loose mapping from physical infrastructure, usually to some kind of virtual infrastructure. But the way that we're talking about things now is much more focused on the applications and services and their purpose and what they're trying to do. And we almost want to think about the infrastructure underneath that as a utility model, similar to, I take my laptop and I plug it into the wall. I assume that I'm going to get power, but I don't really think about how that power is generated and brought to me. I just know that this is going to work. And so what the PaaS or the self-service agile infrastructure is trying to do is to bring that to me as an application developer and an application runner, so that here's my code. I don't really care how you get this running or how you stitch it together and make it able to talk to all the things that it needs to talk to, but I want that to happen, because I have enough things to think about as a developer of this business service that I don't really have time to think about how you glued all together all the pieces underneath it. And part of that is APIs, in that I'm making an API call to give you my code and some metadata and tell you to go run that thing. And then I'm making another API call to scale that thing. And then I'm assuming that thing is going to, when things, monitor my processes. And if my processes fail, it's going to restart those processes for me. Those are the types of things that I start to need to even begin to have something that might feel like an anti-fragile infrastructure. What's anti-fragile? It's the way Taleb describes it is, it's not that the opposite of fragile is, well, first define fragile. Fragile is you put stress on something, it tends to break or fail. The opposite of that is not something that doesn't break when you put stress on it. it's in his mind something that gets better when you put stress on it. And you start to think about, okay, how would we build a software system that when we put stress on it, that system is actually going to get better? And you think about the types of stressors that we put on software systems. One of the biggest ones that we do is change. So the requirements change, the business changes, the market changes, and we need the software to change with it. Traditionally, the way we've responded in infrastructure and operations is that, well, change breaks things. So we're going to make change harder, and we're going to make the change process more disciplined and more process driven, and that's going to slow things down. And if we do that, then we're going to build these robust systems that when we stress them, they don't break. But the types of stressors that we want to put on them, they might not break when we put too much load on it. They might not break when a server goes down and we can fail over. But if I want to add a new feature, all of a sudden that type of stressor is forbidden. And the stressor that the business most wants to place on the systems in this new world of we must innovate or we die is change. And so we now have to start to think about, okay, how do we build systems that not only can we keep them running in terms of safety, but we can also change them quickly and get both?
Donnie, how are you seeing this concept of anti-fragile evolve? And are you seeing it emerging? Are you seeing it evolving? Is this something, seems to be a critical kind of term when you think about scaling your infrastructure? And we're hearing a lot about that. I mean, Cora West talked a lot about this week about, what do they call it? Giphy, Google
Right.
infrastructure. What is it?
For everyone else, yeah.
For everyone else, yeah.
Yeah. I think people are still trying to get a handle on exactly what anti-fragile means in the context of software and infrastructure. I mean, it's easy to think about it when you give like very specific examples. And I haven't had a chance to read through that book myself, but you've seen people talking about the concepts, in person and on Twitter and so on for a while, and like there's examples that it's like, okay, oh sure, that's fine, right? Like the Thai kickboxer like kicks the pole, and then he ends up with really strong shins that he can then kick somebody in the head and he doesn't feel it or whatever. And you're like, okay, sure, that's anti-fragile. But it becomes harder to understand exactly what that means in the context of infrastructure. Like you could argue that, so the Netflix Chaos Monkey approach and whatnot, you could say like, okay, that's sort of anti-fragile, I guess. I mean, or you could just say it's another smoke test in that you're just applying another series of sort of random fuzz testing at an infrastructure level to see what fails. And from some perspective, that's anti-fragile. From some perspective, that's just running a test suite. And so it's a little bit hard for me to come up with examples that I feel like are truly like that is incontrovertibly anti-fragile software development. I mean, maybe Matt has some ideas.
No, actually, I agree with everything that you're saying. I think we have not progressed as a discipline enough yet that we can actually build systems that truly are anti-fragile in and of themselves. That when I start to beat on these things, they actually, in a sense, improve themselves. I don't think we've gotten that. There's a certain missing component that we just don't have yet. So I use the anti-fragile term very loosely to grab from that topic area an idea that it would be great if we could build software that way. So how do we start thinking that way, and how do we start building things? And Chaos Monkey type stuff is one step in the right direction of saying, okay, well, if change is risky because change breaks things, well, then I'm going to make it to where I know where my weak points are, and I enhance my ability to respond better when things attack those weak points. And supposedly over time, the system doesn't get better because the system has the ability to improve itself, but we actually give ourselves better data to work from that we can use to build a better system that's more resilient to these types of changes. But you read some of the things that he talks about, and there's some other some papers out there, for example, that Dick Gabriel wrote about systems that that behave in a sense like the human immune system. Of, when attackers come in to your immune system, if you haven't actually ever seen an attacker before, your immune system is going to be quite weak and not know how to deal with infection. And so one of the ways that we help our kids to not get sick is we get them around kids that are sick. I think the idea then is to not to say, okay, we have to build our systems that way. I don't think we have the tools to do it yet, but at least let's start to think about what would it take to build systems like this, because if we could achieve that, that would be a very powerful tool in our toolkit, and would allow us to maybe do some things that even in the world of microservices and cloud native, that's too risky. But if the system is going to be able to, if you poke it enough, it's just going to keep getting better at responding to those pokes, then okay, well, we can do even more outlandish experiments and innovate even more. But we're probably a few years away from creating a system that is strictly defined as being an anti-fragile system.
Donnie has to run here, so maybe we can just talk for a few more minutes, Matt. In
Sure.
This conversation. But Donnie, thank you for joining us, and you're going to be at the Cloud Foundry Summit this week?
I'm not, unfortunately. It's I think going to be the first one that I won't be at, but I'm definitely going to be checking out the stream.
But I'll see you at GlueCon for sure.
All right, sounds good. See you
I'll
then.
certainly miss you, Donnie.
Yeah, I'll miss it. Have fun. Cheers.
All right, we'll try to. Thanks for talking to me.
Yep, bye.
This concept of anti-fragile kind of then touches on the complexities of distributed architectures. And because they're supposed to be designed to be, when you're working across distributed architectures, right, now you're thinking of database as a service and other types of technologies. That seems where there seems to be more context for the anti-fragile discussion.
Yeah, I think so. Joe Armstrong that created Erlang, he gave this really great talk several years ago, and I believe the title of it was how to build systems that run forever. He walks through several of these areas that are very similar to what we've been talking about today, and ultimately they end up being the core tenets of how Erlang works. The idea of components failing should not ever cause the system to stop working, because if that's ever true, then you can have a very small piece of the puzzle start to behave badly, and that can cause the larger type of service that you're trying to deliver to not be deliverable. And so you think about where Erlang came from, and then telecommunication systems.
Mm-hmm.
If you had a switch in my town fail, and that caused the network for the entire Southeast to come down, that wouldn't be a terribly good architecture, given the fact that we've become so dependent on the ability to communicate with one another instantly from anywhere all the time. Actually, I've been watching these. This show that's no longer on TV, but it's on Netflix now, called Revolution, where the core idea is that someone comes up with a way to basically generate a global EMP that shuts down all power. Not only can nobody use technology, but one of the core things is no one can communicate, and you see the whole fabric of society fall apart. So if the communication systems failed because one microservice failed, that would not be very good. And so we start to think about, okay, we're building these distributed architectures. How can we build the system such that any one component can go out of service, and yet the system can continue to operate? It might operate in a slightly degraded mode. There might be some fallback behavior that is, obviously we built that system for a purpose. So if that microservice fails and is not available for a period of time, we don't want that to not be available forever. We want it to come back. But there might be some, hierarchy of fallback behaviors, whether it's return a dummy data set or hit some cache that's maybe a little bit stale and not the current data. And that will give us good enough service for right now that our customers continue to be able to do the things that they need to be able to do. And then when we restore that service, it automatically just jumps back into the architecture and things continue as they are before.
That is an interesting topic because brings concepts like machine learning into context, and how the systems get smarter and better. And also brings into context, say, a discussion I've just started hearing about is like this two-brain problem that can arise. And have you heard about that?
The split brain? Yeah.
A split brain issue. It seems to really kind of bring that it seems to make that issue more relevant too.
Well, yeah, one of the elephants in the room right now is that, a lot of the stuff that we're talking about from a cloud native perspective, a lot of the patterns that we're describing, they really have this this core idea that the services that you're building are stateless. And yet we know that you cannot build a system that is completely devoid of state. There's always going to be state somewhere, and you shift it around and you move it, but eventually you have to find out, okay, well, how do I deal with the place that the state is going to live? And then you have to start to think about, well, if there's state, there are things that are going to read state, and that's fine, but there are also things that are going to write state. And you want to make sure that those writes are coordinated appropriately so that the data set is actually consistent. There's a spectrum of consistency between complete consistency and eventual consistency, but you want to not have chaos, right? So you have some amount of coordination going on. One of the ways that we do that is by electing leaders. Well, if you have a leader election algorithm, it says, okay, the leader is going to coordinate the writes, and you introduce a network partition, and one side of the system thinks the leader's gone, the other side of the system thinks that the leader's still there. That leader keeps operating, the other side elects a new leader, and now you have essentially two brains in the system, both of which think they're in control, but there's this network partition that is separating them sufficiently that that reality is obscured, and that creates a whole host of problems, some of which are extremely difficult to recover from.
And this is just a natural outcome of building distributed systems. I mean,
right. So I mean, I'm writing a piece this morning for InfoWorld, and they asked me specifically to talk about Spring Cloud, how it relates to self-healing systems. And one of the very first things I do in the piece is I refer to the 8 fallacies of distributed computing.
Mm-hmm.
You familiar with that?
No.
Yeah. So I can probably drop the link to that in the chat there, so you can add that to whatever show notes you put together. So if you pull up that link, he basically gives you these 8 assumptions that people will make when they first get into this realm of building distributed applications. And all of these assumptions are absolutely wrong, but if you make them and you build a system that way, at some point, the fact that you made a wrong assumption about essentially reliability and consistency, the fact that you've distributed your system, so you have components that are flying around out there doing different things, and then you have network interconnects. And the first thing that we realize is, okay, the network is not reliable, it introduces latency, we don't have infinite bandwidth, and it's not secure. So the network itself can cause all sorts of problems for the system, but also because you've separated the components of the system and now they're independently deployable, that means that they can come and go and move around and change. And so even if the network keeps working, the thing that you're talking to on the other side of that network connection might actually be different or fail or change. And so as a developer of living in a system like this, you cannot not think about these things.
Yeah.
but they introduce a lot of overhead into what you're building. So one of the things we're trying to do at Pivotal is to build frameworks and tools and platforms that build a lot of the well-known, well-described boilerplate solutions to dealing with these fallacies into your systems. I use it loosely, but as a service, so that you can go back again to focusing on the business code that you're trying to write and deliver value with, but at the same time, you're able to gain the benefits of these distributed architectures, but also not be naive about it.
Interesting. It brings out the dark side of distributed architectures. It's interesting. And the dark side of containers, really, because if you can, one of the things that everyone loves to talk about containers is their portability and the ability to use them seamlessly with microservices. But I expect if you had containers kind of like, a split brain issue combining with containers, that might lead to some other kind of problems and complexities as well.
Yeah, I mean, I think what it boils down to is, state's a huge problem, but it's a problem that we can't get away from. And over the late first decade of the 2000s, 2005 leading up to around 2010, 11, 12, somewhere in there, we started having to depend much more heavily on multi-core architectures. And we could no longer assume that our code was going to get faster every time a new processor came out, because the clock speeds weren't going up anymore. We were just getting more processors in form of cores. So if we wanted to make our code go faster, we had to learn to scale our code out into multiple processes or multiple threads to take advantage of that power. Right. Well, as soon as you start doing that with shared mutable state, all of the coordination that you have to do not only is expensive, but it's very easy to get wrong. And you have the same, but we built good tools to help programmers build reliable concurrent systems, whether it's better patterns in Java, for example, or some of the other languages decided to build higher level abstractions. You had sort of the actor model that was first really present in Erlang, I guess, but then the Scala community picked up on that. You look at the Clojure community that really went down the path of software transactional memory. You look at Go that has decided to focus on sort of the ideas from communicating sequential processes that Tony Hoare wrote about. And then even Clojure has come back and adopted that as an alternative model. So you have all these tools to build concurrent systems that manage state well, but then that only works within a single process space on a single computer. Now we're saying, okay, we're not just going to scale vertically by having more processors in a single machine. We want to scale horizontally across multiple machines that maybe only have one or two cores. And so the way we get better performance now is to not have more threads in a single process space, but to have more processes on different machines. And as soon as we do that, we realize we've gone back to the beginning of, okay, well, the tools that we have to do this are actually fairly primitive in terms of what your mainstream developer has at their disposal. And so now we're going through that process again of, okay, what does it look like to do this well and build abstractions that people can work with productively and correctly and still build systems like this. So in a sense, we go through these cycles in engineering of solving the same set of problems for a given context, and then we move the context, but the problems come with us, and then we have to resolve those problems. We're doing that in the container space right now. We solved a lot of the problems that we're trying to solve with containers today. We solve those for VMs. You look at the state of containers today, it looks a lot like the state of virtual machines in 2003. And we've had 12 years to build better tools and patterns and techniques for managing VMs. And then we go to containers. It's like, okay, we have to solve the virtual networking problem again. for containers. And we're going through the same growing pains of and making some of the same mistakes that were made early on with VMs of doing virtual networks. So there's a sense in which we continue to create pain for ourselves by reinventing solutions to the same problems in a different space. But there's also a sense in which we need that evolution to get the strengths that we got from the previous generation of technology, but solve some of its weaknesses in the way containers, they do allow us to pack an infrastructure a little more effectively, and they can allow us to be more portable where VMs struggled with that. Yeah. But then the problems that we solve with VMs don't go away.
Well, Matt, that's a great way to end this conversation. Thank you very much for taking this time. It's been really interesting for me to think a little bit differently about state, and and then also the context of the language that we use to better understand distributed architectures. And I really look forward to following up and having more conversations on this topic. So thank you very much for joining us today.
Yeah, thank you very much. This has been a lot of fun. I look forward to talking about these things some more maybe later on.
You bet. Well, that'll end it for today. My name is Alex Williams with the New Stack. This is the New Stack Analysts. We'll be back again soon. Thank you very much. Bye-bye. Our show this week is brought to you by Pivotal. Pivotal considers themselves on a mission to modernize IT. They have a portfolio of cloud and data products that embody agile engineering disciplines. You can find them at pivotal.io. Audio editing and sound design for the New Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. I hope to see you again for the New Stack Analyst podcast. Bye-bye.